Good afternoon, everyone. Thanks for joining. I think we're just going to give it a couple more minutes as folks continue to join us. Right. Good afternoon, everyone. Thank you for joining. I'm going to kick us off now because we have a lot to cover today, and this course has been approved by the Department of State for in-service training credit as follows. 2 hours on topic 2, the Uniform Code, and this is course number T02073413. So you will be eligible for credit. License numbers should have been presented in the intake form through WebEx. In the event that folks are unable to do that, we will be following up with an email to make sure that everyone gets credit for this course who needs it. Next slide, please. So my name is Bill Obercare. I'm a program manager on NYSERDA's Clean Energy Siting team. And together with Paul Rogers, who is a founding principal at ESRG, or Energy Safety Response Group, we are going to be delivering the first battery energy storage for code officials course. This is covering the 2025 Fire Code of New York State, Section 1207, which just went into effect on December 31st of last year. So excited to have you all join us for this inaugural presentation of this course. Next slide, please. Before we get into the nitty-gritty of the fire code, which don't worry, there will be plenty of it, I'm going to do a brief introduction into what energy storage is, why we need it, why it's important, so that we're all on the same page before we start talking about fire. Energy storage is exactly what it sounds like. It's a giant battery for the grid. It's going to store electricity in periods where electricity is not in such high demand or when there is excess renewable production, and then it's going to release that energy when power is in higher demand throughout the electric grid. If folks don't know this, it's very important to understand this going into the presentation. Grid function is a giant balancing act between grid's power supply and grid power demand. Batteries are really one of the only technologies out there that can serve as both supply and demand. So if the goal is to balance the two continuously over time, I would hope that it's self-evident why technology that can serve as both supply and demand, depending on what's needed, would be so critical to grid infrastructure moving forward. In addition to that, energy storage makes the grid more resilient. Grid hardening, it is dispatchable power, so power that can be dispatched when needed. And for distributed technologies, that power can also be dispatched where needed, which is critical. And at the risk of bearing the lead, batteries have also been proven to save us money in our electric bills, our utility costs in the long term. Next slide, please. I'm going to zoom in on the image at the bottom of the previous slide here just to show how this works. Starting on the left, you can see that we can charge a battery. Those are generation sources. So at the top, you'll see renewable, hydro, wind, and solar. And at the bottom, you'll see a transmission line that is a stand-in for our coal, nuclear, gas, other sources of generation. Those can all be used to charge the battery. And then the battery is able to discharge either into a load, which is what the home signifies here. That's a residential electric load. Could also be a commercial electric load, industrial electric load, or it can discharge straight into the grid, which is that bottom arrow going over to the transmission pole, and then can be discharged from the grid into a local electric load. So as you can see here, the battery is a very versatile technology. Next slide, please. This chart is from the National Electric Manufacturers Association. It shows national net electricity consumption by sector. We can see consumption is increasing in different sectors, and we're looking at a roughly 25 to 35% electricity demand increase in the next 25 years. So that's a significant increase and a consistent increase as well. Energy storage is going to be necessary to meet this growing demand and prevent brownouts and blackouts and ensure reliability of our grid. Next slide, please. So when we talk about batteries, it's important to understand that we are not always only talking about one thing. For the purpose of this presentation, we are largely going to be focused on lithium-ion batteries, though there will be some information that is specific to other technologies and chemistries. This slide is just to show that there are many different types of energy storage. On the bottom left, you'll see electrochemical. That's most of the batteries that we are familiar with. Lead acid, lithium ion, sodium sulfur, flow batteries, all those ones that are really dominant in the conversation about energy storage typically fall under electrochemical. Although in New York, I believe our highest concentration of storage is in the top left, pump hydro, which is basically there's a reservoir. When the power is cheap, water is pumped toward the top of the hill and then released when power is more expensive or in higher demand to be able to spin a turbine moving down the hill using gravity. We're not going to talk too much about mechanical, thermal, or chemical storage, but it is important to understand that when we talk about energy storage, technically the whole family of technologies is included. Although, as I said, for the most part, we are going to be focusing on lithium-ion batteries, which on the next slide will become evident why that is. So we have a table coming up here that shows different types of batteries with different characteristics of each in the rows. Round trip efficiency means how much energy that is charged into the battery can be discharged. You see lithium ion at the front of the pack with 85 to 95%. So minimal losses between charging and discharging in the lithium ion, especially relative to the other technologies here. Duration is the period of time over which the battery discharges. Critically, this is one of the areas where lithium ion is not leading the pack. Lithium ion, according to this, is 15 minutes to 4 hours. Actually, it's closer to 4 hours now as a rule for lithium ion, but still we see flow batteries that have 12-hour duration, which means that they can charge their capacity over 12 hours instead of 4, which when it comes to meeting peak demand and other situations like that are more rare, that can be very useful to have that longer duration period. Time to build, we see pretty consistent numbers across technology. Here's where we start to get to the reasons that lithium ion is dominant in the market. Low operating cost, that is huge. No one wants to pay more for electricity than they absolutely have to. Low operating cost makes that the case. Space required, small for lithium ion. That means there's a high energy density, which means that we see lithium ion batteries spending less on land leases and rent and things of that nature to be able to have the space for the battery to operate. Cycle life, again, lithium ion is toward the top of the pack, but not absolutely dominant here. And then finally, when we go to technology maturity, we see that lithium ion is at commercial. Lead acid is mature, primarily due to the auto industry, but that's really where we see lithium ion rise to the front of the pack for grid scale operations. It is at the highest level of commercial maturity, and that's really why we see it as the dominant technology in the market. We've got our first quiz question on the next slide. This is going to be critical, especially for those who are interested in getting the in-service credits from Department of State. These quiz questions are designed to show that you are engaged, that you are paying attention. So it's very important to answer these questions, particularly if you want credit. We do typically submit the answer logs to Department of State along with the other material that they require from us. So the first question here, why are lithium-ion energy storage systems dominating the current market? Is it because of high energy density, declining costs, high round trip efficiency, or all of the above? Give folks another minute to answer that. You can answer that right in Slido. And I think since we just covered this one, and because we have a lot to cover, I'm going to go ahead and confirm that the correct answer is D, all of the above. Next slide, please. This is going to be important throughout the presentation, so I would urge folks to perk up your ears here. These are the fundamental building blocks of a battery. We start with the cell, which is the tiniest modular unit. They can be either cylindrical, which is like the AA batteries that you're probably accustomed to, which are lead acid, prismatic, which has a little bit of a box shape, and then a pouch is the third type. Those are the fundamental building blocks of the energy storage system. Cells wired together create a module, and then modules wired together create a rack. Racks wired together create an installation. This is going to be relevant information when we talk about the large-scale fire testing or the UL 9540A testing, because that test can be done and often is done at each of these levels. So it's just going to be important to kind of commit this to your short-term memory and understand that cells are the smallest, modules are cells wired together, and then racks are modules wired together. Next slide, please. And then we have the battery management system, or the BMS, not to be confused with the building management system, although it does perform a similar function to a building management system if we have any buildings and facilities folks in the audience. This is going to be the eyes and the ears and the brain of the energy storage system. It's going to be able to monitor each individual cell within the system. It's going to be able to send out alarms automatically if there are issues or potential issues, and many BMS can actually isolate cells within the system if there is an issue, which we will talk about later on in the presentation. And then finally, on the next slide, we're going to go through a little bit more about how I said at the top, this is the energy storage is the technology that can serve as both supply and demand, and that makes it critical. Well, in addition to that, energy storage is often referred to as the Swiss Army knife of the grid. It is a very versatile technology in many ways. On the screen here, you see several different use cases for energy storage grouped by different sort of end users or customers to the energy storage. So energy storage has functions for utilities. We can reduce fossil fuel on peaker plants. We can defer upgrade costs to the distribution network. For grid operators at the NISO, there are a whole host of benefits that energy storage can provide, including backstart, capacity capabilities, frequency regulation, and ancillary services. For commercial consumers, we can use batteries for peak shaving and to lower the overall peak charge on the electric bill. And for residential customers, can use batteries to back up power or to get more out of a rooftop solar system to be able to stretch that solar power to be giving net metering credits through the evening when residential use is typically the highest. And with that, I'm going to turn it over to my esteemed colleague, Paul Rogers, to take us through some battery failure sequences and diagnostics.
Yeah, great. Thanks, Bill. And I'm glad you did mention that a lot of the stuff that we'll be talking about today will be dealing with lithium ion, which is going to be the chemistry that we're going to most frequently see out there. So you can move to the next slide. As you can see in this slide right here, we talk a little bit about the hazards associated with lithium-ion batteries. This is well documented. This testing has been going on since 2013. We are aware of all of these different hazards and failure modes that are associated with it. And the code actually does a good job of trying to protect against them. And everyone has heard that thing about thermal runaway. It generally happens in a cell. And the thermal runaway doesn't necessarily mean fire, but it would possibly release some gases as a result of it. Reignition is something that we make sure that the fire department does know about if they were to respond during a failure, if there was some sort of ignition and a reignition. That is also documented, along with the idea that the fire department also needs to know about stranded energy. So even if these things shut down, regardless of the chemistry, there could be stranded energy still within the battery where it's not going in, it's not going out. Deflagration is something that is covered in listings, and Bill will get into that a little bit. Just making sure that we can actually control a deflagration from taking place, or in some cases manage the deflagration in the event that we did see that during a failure event. Electrical risks are always appropriate or for any type of electrical equipment where we're always concerned about electrical risk. And again, we go to the fire department to make sure that they understand that on their end. And then, like any fire, smoke and gas release is typical with any type of failure that may take place with any battery energy storage system, even though we do recognize it here in the lithium ion. And the failure modes, again, are well documented. The thermal abuse and overheating of a battery or some sort of external heating from the exterior of the actual cabinet itself is something that we have to be concerned about on that end. And as Bill mentioned before, the battery management system does a good job of actually trying to prevent that from taking place, or actually act accordingly based on whether overheating or external heating that may take place. Electrical abuse, as far as overcharging or over discharging, is something that is also a concern. And again, we do have parameters in place in the code to make sure that we look at that, and also in the listing. Mechanical abuse, like anything, if you impact it, puncture, crush it, or anything, it will lead to some sort of failure. And factory defects is something that we should be aware of. And Will showed you a cell there. There could be, out of billions of cells that are made, one that just may not have passed muster and could be defective. But the nice part is one of the listings that is required in the state code is UL 1973, which Bill will go into, where they actually account for a single cell failure inside the actual module itself to show that there is no spread of the event inside the module. So we're covered in that way too. The chances of having two defective cells next to each other are very, very slim. And then also we want to make sure that we look at any type of components that may be associated with it, and any protections that need to be addressed on that end to make sure that we have the state of health of the battery itself in good order on that. And you can go to the next slide. This is a graph that came out in 2024, and you can see back in 2018, we didn't have that many battery energy storage systems in place, and the code really wasn't mature at that particular time. So we did have some failures that took place, and as you can see, that little shaded area in blue, that's the number of installations that have gone out in the United States of America, and that information there shows that as we get more and more in there, we're having less and less failures. And that's as a result of people following the code and all the requirements that are in place for the product itself. The codes are one thing, but the product itself and the listings that are associated. And that's why it's important that we take a look at that. If you are a code reviewer, to make sure that they're having those proper listings, will give you some sort of reduction in risk of an event from taking place. You can go to the next slide. Okay, this here is really just kind of showing you, and I believe there's other sections to this. If you can kind of hit it again, I believe they pop up. This is really just showing how yeah, thank you for that. This is just showing how there is an area there that we try to prevent anything from taking place. And then if there is something that would take place, we want to make sure that we can manage it. And these are all the different things that are in place to try to prevent it. And then if it did start to fail, how do we manage that failure? And it's important that we take a look at that and making sure that the smoke detection is there or gas detection, whatever is in place to make sure that everything that is supposed to be working on game day is working. And that's important. And that also has to be looked at when we're doing inspections on these things when they're up and running. You can go to the next slide. I'm going to hand it off to Bill at this particular point. Bill, you can take it from here.
Thanks, Paul. I'm just going to jump in to give folks a little bit of history of the code evolution and development process here in New York before we get back to Paul, the much more interesting speaker, saying much more interesting things. Brief history lesson to be able to put those things that Paul is going to say in context. So we really start in 2016. We get the first edition of UL 9540. We will get into exactly what that means in detail, but that's the key UL certification for energy storage systems. In 2017, we have the first edition of UL 9540A, and this standard is created in no small part thanks to Paul and the work the FDNY was doing at the time in the city of New York, so thanks to them for that. But 9540A, as Paul will explain later, is the large-scale fire test for energy storage systems. Edition 1 comes out in 2017. In 2018, the International Code Council released their first chapter on energy storage systems in the International Fire Code. And it's important to note that these 2018 regulations are not really mature yet in the 2018 IFC. And then 2019, we have this kind of watershed year nationally and in New York for lithium-ion energy storage regulations. We get NFPA 855, the 2020 edition, which is really the parent standard for pretty much all modern lithium-ion energy storage regulations. We are on, I think, the third or fourth edition of NFPA 855 now. The first was released in 2019. 2020 855 is what it's called. The same year, the fourth edition of UL 9540A, which again is the large-scale fire test, was released. And the International Code Council released the draft 2021 IFC, which really is based on that 2020 NFPA 855 standard. And this is when we start to see sophisticated, robust, mature code requirements for lithium-ion energy storage. So 2019 is really the watershed year. And then in the city of New York as well, FDNY published their rule, RCNY 60801, for outdoor lithium-ion energy storage systems for the city of New York. So 2019 is really the huge year for energy storage regulations. And we're coming up on a decade now, and improvements have been made since. Like in 2023, NFPA updated the 855, and in 24, the International Code Council updated the International Fire Code Standard, and that 23 NFPA 855 and the 2024 IFC, they are related to each other. So the 2024 IFC is drawing from the 2023 855, and they are the basis of Section 1207 in the 2025 New York State Fire Code. So it's really those two standards at the bottom of this slide that are informing a lot of what New York has done. Next slide, please. And then in New York specifically, in 2019, there was an energy storage supplemental rule, which was adopted by New York State's Code Council between code cycles. So in 2019, New York is the first to adopt those new requirements in the 2020 855 and the draft 21 IFC. The next state behind New York to do that is California, who adopted them in July 2021. So there's a significant lead time in New York on adopting the most up-to-date and stringent energy storage regulations in 2019. Then we have the 2020 Fire Code of New York State, which codified and finalized those 2019 amendments that were adopted between code cycles. Those were implemented on May 12th of 2020. And again, the next state to do that was California in July of 2021. In March 2025, the Fire Safety Working Group fire code recommendations were issued in their most mature form before adoption for comment. I'll go into those on the next slide. In July of 2025, the Code Council formally adopted the Fire Safety Working Group recommendations into the code that went into effect on December 31st of 2025. For folks who don't know, the Fire Safety Working Group is Governor Hochul's effort to address 3 grid-scale energy storage system fires that happened in the summer of 2023. So within 2 months of each other, 3 grid-scale systems caught fire. In response to that, Governor Hochul assembled a working group of NYSERDA, Department of State, Office of Fire Prevention Control, Department of Homeland Security and Emergency Services, Department of Public Service, folks who were involved in energy storage development. We brought in then Paul Rogers and his team at ESRG, DNV, HDR, other national experts to support our work. Part of the deliverables from the Fire Safety Working Group were these code recommendations that you see on the screen here. I'm not going to belabor these because we're going to cover them all throughout the presentation. I've done entire presentations just on these recommendations, so I'm going to gloss over it quickly now and just move ahead to the next slide to talk about what the Fire Safety Working Group has done to make sure that all of these code recommendations are actually enforced. Because as many folks on this call may know, next slide, please, for peer review. As many folks on the call may know, regulations are only as good as their enforcement. You can regulate all you like, and if there's no one there to make sure that those regulations are followed, they're not very useful. So through the work of the Fire Safety Working Group, we discovered that AHJs in New York, as a home rule state, need more support in reviewing energy storage projects. This is highly technical, critical infrastructure, and it didn't seem fair to anyone involved to have folks who may have never seen energy storage plans before be the only line of defense in making sure these projects are built in accordance with the fire code and industry best practices. So the 2020 Fire Code of New York State had this optional provision to require a peer review, which is an independent third-party design review by a special expert. What the Fire Safety Working Group decided to do was make that mandatory, so it's no longer a discretionary authority. Every project over 600 kilowatt hours needs to have this happen every time. And then not only that, but NYSERDA issued a competitive procurement to select who we believe to be the leading experts in the country on energy storage system safety and development. Those are Camelot Energy Group, DNV, and ESRG, represented by Paul on this presentation today. So those are the folks who are going to be reviewing projects over 600 kilowatt hours on behalf of NYSERDA. So we brought folks with real credentials to bear on this issue, again, to make sure that these regulations as written are actually being practiced, that they're being enforced, and that we're making sure that designs are code compliant so that we can then build systems that are code compliant. And folks who are familiar with construction may also know that just because a system is designed in a certain way does not mean that that system will be built in the same way. So the peer review team is actually working with NYSERDA's inspection team to be able to go over the plans prior to the NYSERDA field inspection to make sure that the designs approved by the peer review team are aligned with the projects as they are built in the field. So we've built really this kind of sophisticated enforcement machine within NYSERDA as a redundancy. So it's not an infringement of home rule power. It's a redundancy. It's happening alongside the permitting authority that it still rests with the local authorities having jurisdiction and the folks who are likely attending and viewing this webinar. Next slide, please. Just one more note on peer review. That is a code requirement now, so that must be done for all projects. NYSERDA will issue a report from our peer review process that is designed to be handed to the authority having jurisdiction so that we don't have duplication of effort whereby one project is getting peer reviewed 5, 10 times, 2, 3, 4 times. So we will produce a report that shows the results of what NYSERDA's peer review team found, and then that report should make it to the AHJ, and ideally that would satisfy the code requirement, but if the AHJ determines that more review is necessary, the code does give the AHJ the authority to do that. So I said special expert before as the entity who conducts the peer review. Special expert is a term that is defined by the code. You can either be a licensed PE in the state of New York or accredited by specific education and or experience with energy storage systems and have demonstrated technical knowledge and experience in design and operations of energy storage systems. That is actually defined in a bit more detail in the code, which is in the next slide. If we could go to that, please. This is the actual code, this is what the peer reviewers are reviewing. So if they can demonstrate experience with reviewing these types of documents, they are going to qualify as a special expert more likely than not. So we see a bunch of technical documentation here, and this is what the Fire Safety Working Group found. It's kind of unfair to expect someone who has never seen any of this before to be able to read and understand all of it in one time through, and that is really the reason for the creation of the peer review process and why NYSERDA has invested in special experts to be able to carry this out. It's really to make sure that we have the folks who are the most familiar with this type of documentation in the country reviewing that documentation on behalf of New York's communities. And we've got another quiz question on the next slide before I turn it back over to Paul. I will give you a head start on the question. Who can perform peer review for energy storage systems? Is it the town supervisor, fire department chief, a qualified special expert, or the landowner? I will give folks a second to fill out your answer on Slido. Again, we are sending these answers to Department of State, and they do serve as verification that folks are engaged, paying attention, and qualifies you for those in-service credit hours. The answer here is C, a qualified special expert per the 2025 Fire Code of New York State is the only entity that can perform a peer review for energy storage. You can be a qualified special expert by being a licensed New York State professional engineer or by having special expert qualifications. And with that, I will turn it over to Paul to jump into the Fire Code itself.
Yeah, thanks, Bill. Yeah, very important topic right there is to make sure that these things are going in properly and they are following the code, a very technical code. And as you mentioned, Bill, a lot of people may not have the bandwidth. And also, people should know that those peer review are there just to help. The ultimate authority is the local jurisdiction on that. So, okay, let's get into the section 1207, right? And we'll get into just some tables here. This is this is just showing you the different chemistries that are out there and where it starts to pick up in the fire code. You can see in lithium ion, the fire code starts at 20 kilowatt hours. That doesn't mean that residential systems get a free ride because most of the residential system has to be 20 and below. They still have their own criteria, but I just wanted to point that out. But this is the threshold where we start to take a look at these batteries used in the way of the different use cases that we'll see out there. So you can move to the next slide there. Okay, important here during the submission, as I said, there's a lot of things that come into play during these submissions. And as Bill kind of alluded to, some of the code officials may have not seen this before, but there is a lot, and it could be a book on the information that is required. So we're not trying to intimidate anyone with that, but there is a lot of information that's out there. And there's subcategories into this bullet list. If you have the time right now to take a screenshot of this, I would suggest that you do take a screenshot, even though this will be available, but it will be readily available if you did take a screenshot of this particular one right here. This is most of the stuff that needs to be incorporated in there on that end. But even to the point of listings and making sure that these things are listed properly, I would recommend that even though we do ask for listings, and I would also ask for them to actually provide that listing and making sure that listing is provided as part of the submission package. And again, the last bullet there that talks about the peer reviewer that Bill kind of went into, we understood the importance of that and making sure that if the town is bringing in their own peer review on that end, paid for by the developer, that they understand how this code works, because it is very technical and people will start to understand it But right now, since it's so new, there are a lot of people who are not totally familiar with it. So we just want to make sure that they're doing and protecting you properly to make sure that you understand the qualifications that are needed. So you can go to the next slide. Okay. Um, so this is for the utility companies. So the utility companies are also they still have to follow the fire code. They used to get an exemption for this, but now when they're putting these battery energy storage systems in there, they're going to have to follow that fire code. And it's important that they know that they are also they do not have that exemption where there was an exemption at one time. Years ago, they used to, and they still have to follow the NERC and FERC regulations. And people felt that was good enough, but now they still need to follow that, but they also need to follow the New York State fire code when they're installing them as far as utility use. So we can go on to the next slide. All right, this gets into the hazardous mitigation analysis. So this is a desktop review. It's a report that it looks at a couple of different failure modes. It's in there and how the battery will try to prevent or mitigate a failure, so we don't get a failure. And we, it is something that is done usually by a professional engineer. Um, and it is part of the submission package that is put out there. There's a couple of different ways to do those hazard mitigation analysis. One way that we see out there is, which we'll go to the next slide. Um, yeah, yeah. This is just one way of how we look at it. We look at this from a threat, right? And the barriers to actually try to prevent that threat from taking place. Um, and then finally, if there is a hazard, what are the consequences to that hazard, and what what happens, what barriers are in place. So we can move to the next slide, this one. Pre so The pre-2020 lithium-ion systems exceeding the threshold did require an FMEA and an approved hazard mitigation analysis, so that's still in place today. The analysis there must be to evaluate the thermal detection, right? And that's usually done as part of your listing in UL 1973 that Bill kind of went into on how that thermal runaway is actually detected, and how the BMS should interact with that to make sure that we do not get the thermal runaway from taking place. But also we want to make sure that the fire department and the responder safety is also incorporated into that. Bill, I see you pop in there. You want to add to this?
Yeah, I just want to add that this, we didn't put it in the slides, but this is actually section 1107 of the fire code and not 1207. And I just want to add the detail that this is the only retroactive looking provision in the 2025 fire code. So if folks are looking back at existing systems, that is defined in 1107, and this is really the only piece of the fire code that deals with existing development.
Great. Yeah, that's a good add in there, Bill, that you made that reference. I appreciate you actually putting that in there. We can go to the next slide, please. Yeah, so as you can see here in the picture here, this is large scale fire testing, and you can see how the orientation that they have right now, and this really proved the validation of safety. And what they do in this particular test, the large scale fire testing 9540A, is they're actually failing the system itself. And they want to make sure that if this thing were to fail, that it will not propagate outside the particular cabinet. And again, we're talking about outdoor cabinets, or sometimes it's referred to the unit in the actual 9540A testing. But if this thing were to actually fail, it demonstrates that the fire will not spread any further than the actual unit. And this is really a good picture. And if you take a look at the picture, the test has to be set up in the orientation in which the battery energy storage system will be installed. So you can see there's one on each side of it. That's what they planned on installing. That's what they recommend in their guides. and they need to show that if this thing were to fail, that it would not go to either side. In this case, where a battery energy storage system of the same type would be what they. You can also see, and we'll probably hit this again, but you can also see the limited space in between there. So the separation distance in there is pretty, is not really too wide, and we'll address that later on. But it's important to know that this is a data collection test, and there's a lot of different things that come out of there that help to actually validate the installation itself, and a lot of things that are associated with the installation and the battery system itself, with the deflagration control and heat release rates and all these other different data that can be utilized by the code official or the peer review in order to validate some of the information that they may need to make sure that this system will not have any interaction outside the system itself. So we can move on to the next slide. Okay, this is a question right here, and I hope I covered it properly, but the large-scale fire testing is not supposed to demonstrate, A, the energy storage unit will never catch fire, B, that the fire will not spread to an adjacent storage system, C, that the unit will contain the fire for the duration of the assembly resistance rating. So I'll give you couple of seconds. Hopefully this is a pretty easy one for everyone. The answer is A, right? We can never say that something can never catch fire, right? It's a fire prevention code, not a fire elimination code. So it's important to know that we try to reduce the risk significantly to try to prevent anything from taking place with all the different layers of safety in there. They did a really pretty good job, very good job actually, with the regulatory infrastructure to try to prevent a fire from taking place. But even if the fire did take place, you could take a look at Woody. We are trying to make sure that if that fire does take place, it doesn't spread outside the particular cabinet there. We can go to the next slide. All right. So here's something that we have in the code, and it's called a hazard support team. So speaking from the mindset of a firefighter, where I did 25 years with the New York City Fire Department, everyone should understand that if the fire department were to show up to the scene, a lot of these places that will be out there will not have anyone that they can actually talk to. So they really wanted to make sure that the fire department, was not left out there at 3 o'clock in the morning with no one to actually have a reach back to. So the code adopted the hazard support team. At one time, it used to be an optional, and now it is mandatory that they have a subject matter expert and a hazard support team. So here's how it works. In the event that the fire department gets called there from a fire alarm, and they see nothing showing, for instance, there should be a number on signage that they can actually call to reach out to the subject matter expert to try to find out the state of health of the battery. And they can access that, or the subject matter expert should be able to access the battery management system to take a look to see whether this is something that is a problem for them, or whether they can actually turn around and go back to their quarters because they don't see anything. They'll also have the closed circuit TV that is also required for them to take a look at it on their end. But let's use the scenario that it is on fire. They're going to be in contact with the fire department. I know it says here within 15 minutes, but technically in the code it says immediately, and by code language, immediately is up to 15 minutes. So I wanted to make sure that everyone knew that. But in the event that the fire department said, okay, yeah, we do have something going here, and I need a team here, he can activate, or she can activate, that hazard support team to make sure that they actually show up to the scene. And the code requires 4 hours, and I do hear a lot of people complaining, well, 4 hours is a long time. I can also tell you that no other place in the country has such a stringent number like that. That 4 hours is actually very aggressive, And sitting on the code committee, some people were kind of surprised that we were able to get in there. So I think the Department of State did a good job on getting that into there. And it doesn't mean that they can't be there within 30 minutes. It just means that the limit is 4 hours to get to the actual scene. And what do they do when they get there? They're there to just give guidance to the fire department and to take over the scene after the incident commander releases it to them. And that is the handoff procedure, right? We always want a responsible party when we're handing something off. And that hazard support team, right? They could serve as a fire watch. Uh, as I mentioned before, there could be a reignition that could take place. We've seen that in testing, and they could actually notify the fire department if that happens. Instead of the fire department standing there watching it for all that time, the hazard support team can take those duties on their end. And then after everything is completely finished, we don't see any reignition or anything like that. They can start the decommissioning process during that particular time and get the people in place to actually get the systems out of there. As you can see here, we have the word evacuate, but that's for a building. Evacuation is a big deal. We don't usually see evacuations for products of combustion. And what I mean by that is smoke. That's something that is very rarely done. When I teach fire service, I do mention that to them. But inside a building where the smoke is actually trapped, yeah, we're probably going to evacuate the building to get the people out of there because we don't want them breathing that smoke in that's inside the building and not getting lifted out into the open air like that. So it's important that you know that. And I do want to add this. This is similar to what we had here in New York City. We do know it works. We've actually used it, and the proof of concept works, and it works pretty well too. So for those who are in the fire service that are listening here, again, this was put in place really to make sure that there was help, and we know, especially on the volunteer side, that help or that handoff is really important for them. So that was looked at to make sure that we were covering both the career and the volunteer people to actually give them some sort of needed relief, that they're not holding the incident and waiting for someone with no set time frame to get there. So you can move to the next slide. So some of the qualifications that that the hazard support personnel needs, right? We want to make sure that they understand operations of an energy storage facility, and that they're trained in that and how it works, and so they can give good information to the actual incident commander during an emergency, because they do rely on that information. I can tell you again, during my time, I did want to know someone who knew about the facility when I showed up to the scene that could give me good information. It's really important for them to know that. They also need to have knowledge of the fire safety plan, any pre-incident plans that are out there. And then, of course, the emergency operations plan on that. And those emergency operation plans need to be approved by the fire service that would be responding to them. And also the hazard mitigation analysis. They should understand how this thing should be protected properly to make sure that the fire service during their response should not get hurt. The other thing that we put in there, and this is the first of its kind, is we wanted to make sure that they completed incident command system. So this is a FEMA course that's online. 100, 200, 700. And basically what that does, it just gives them the jargon that they would need and understand during an incident command system. So when the fire department shows up to the scene, they will institute what they call the incident command system. It's basically a management tool where the fire department will have certain language that there. So we want to make sure that those hazard support personnel don't hear that language for the first time and wonder what the heck it is. So these courses cover that, and they cover what takes place, how a unified command system could be activated, and the list goes on and on and on. And I won't go into that too deep here on this particular one, but those courses need to be accomplished on that side. So we can move on to the next. Great. Commissioning plans. When these things are actually show up to the scene, usually the cells are out of balance. We need to make sure that we have a commissioning plan in place on how they actually plan to get these things that the battery energy storage all balanced and ready to go with the interconnection and making sure everything is working properly. And it is a time that the fire department should be aware. I'm an advocate of making sure that we notify the fire department on that, but they should also be making sure that these things are installed according to the plans and the manufacturer's specs, right? That's important. And all the testing components work during that particular time. For instance, if they tell you that the battery management system can remotely shut it off, or they can remotely, we may want to exercise that to make sure that they do that after the commissioning is done, and before we actually give it the operating permit that it needs, or the special use permit that is needed for that particular battery energy storage system to go in place. The plan must be approved again by the local jurisdiction on how they're doing it. And a report for the final inspection needs to be delivered to the authority having jurisdiction in that particular jurisdiction area where it is. It also includes a decommissioning plan. So what happens after the end of life? So there is a decommissioning plan that needs to go in and that needs to be put in place during that particular time. And I have seen people ask for decommissioning plans for things that have, if there was a fire. Now, you have to be careful on that one because it's hard to know the extent of the damage. So a decommissioning plan for end of life is what the code is looking at, not the emergency decommissioning plan. That will be done in real time with the authority having jurisdiction and making sure that everyone is inclusive on the plan on what they plan to do in order to get these systems, these damaged systems out of there. And that gets a little bit more extensive on that end. So we can move to the next slide. Okay, so this is really just showing, like here's a system that has been made. They took out the cells and they removed the cells, and there's a whole mess of stuff that goes on when they do remove those cells, checking for any stranded energy, how to reduce that stranded energy, and the list goes on and on and on with all these different things that are in there. But it's important that the AHJ knows prior to the decommissioning that they approve that decommissioning plan before any of that work takes place. And the description of the activities and how they plan to actually remove it from the facility. Like, for instance, what routes would they take through the town, how they're going to package these, what they call DDR batteries, damaged, defective, and recall batteries, and are they doing it according to the actual standards to put them on the road properly. So all of that stuff should be incorporated into that, and we can talk more about that offline, but we can move on to the next slide. Okay, the operation and maintenance manual, they're going to be different depending on what type of battery energy storage system that you're actually using. So it's something that I would actually have you take a look at to make sure that they're doing things according to what the manufacturer's specifications are on that end. And it's important that you do that. It does outline the required maintenance, and that word required means it's kind of mandatory. It's not maybe. No, this is what you should be doing on that end, and that's important for them on their during the inspections and any testing schedules and logs that they have that could be available for the local jurisdiction on their end. We can move to the next slide. Okay, so here's what we have here, and I think this was a good add-on. Standard of care when these things are up and running, and making sure that we have someone that has eyes on them every so often. So the code did institute something where they'll have periodic inspections that needs to be tested, and that report should go back to the AHJ, and those records need to be maintained. And we need to make sure that the people that are operating these things, they're owned and operated, that they're doing that work, because that again will reduce the risk of an event. And the standard of care is important throughout the life of the system itself. Like anything, like your car would be, making sure that you change your oil, for instance, on a regular basis. We can go to the next slide. Okay, and this is what I mentioned before. A third-party inspection must be performed by a registered, licensed professional engineer from the state of New York, of course, or a special expert every 3 years, or more frequent as decided by the local fire official. So it gives you a little latitude there. It's in the section, and it's section 1207.14.1. And all of the things are appropriately listed there on what needs to be looked at as far as the inspection is concerned. We can go on to the next slide. Bill, I think this is you.
I'll hop back in here. Thank you, Paul. Um, so Paul talked earlier about the UL 9548 test. And the point of that test is to create data to make informed data-driven decisions about siting. The UL 9540 is an equipment listing. It's much more binary. It's much more pass-fail. For the UL 9540 equipment listing, you either have that or you don't have that. Versus the UL 9540A test is a lot more qualitative than that. There's information that you use to make sound data-driven decisions, as I said. So this is the UL 9540 equipment listing that we're going to talk about right now. That is Underwriters Laboratories certifying that everything, all of the components and subcomponents of the system work safely in harmony together. As Paul has mentioned a number of times throughout this presentation, there are other UL listings that are necessary to get the UL 9540 listing. So for instance, the inverter has to have the UL 1741 listing if the system is going to be grid connected, which almost all of them are. The cells need to be UL listed. So there are all these kind of sub listings that go into the UL 9540 listing. So one thing that we, I think, hear a lot in the field is that this is a new technology with nascent immature regulations. I think that's hopefully demonstrably untrue by this presentation. I really hope folks walk away from this getting a better sense of exactly how much oversight, how much testing, how much review, how much approval goes into each and every one of these. And this is from the Underwriters Laboratory. It is probably the most important certification. And as I said, there are sub-certifications within it, including a full deflagration analysis, which is an explosion analysis that needs to be done as part of this as well, which we will get into later. And I think Paul mentioned it before too. So this is a really critical component of energy storage safety, the UL 9540 equipment listing. It is required by code, not to be confused with the UL 9540 field listing. The UL 9540 field listing is not a suitable replacement for the UL 9540 equipment listing. The UL 9540 equipment listing is required by code, and the field listing is not a suitable replacement for that. That is crucial to understand. The point of the UL 9540 field listing goes to this sort of third bullet here of non-identical repairs and retrofits. A field listing is something whereby if we have a system that's already in the field and one of the subcomponents is recalled or needs to be replaced with a non-identical piece of equipment, the 9540 field listing can be used then as a supplement. So we're going to say we can't take all this equipment back to the lab and recertify it. So we're going to have folks, recertify this project in the field because there's this one minor repair that's taking place. So that I think is helpful to understand at the highest level of the difference between the two. And again, the UL 9540 equipment listing is required by code. The UL 9540 field listing is not a suitable replacement for the equipment listing. Next slide, please, to get a little bit more into some of those details. The retrofits. So when we are in a situation where a system is already built and a component needs to be replaced, presumably with non-identical equipment, that requires a building permit. So when these systems are being altered, they do need to be reevaluated by the local AHJ. And in certain cases, that will also trigger a reevaluation from NYSERDA's peer review, just depending on the severity of the replacements or the retrofits that are happening out in the field. Next slide, please. We went through a little bit about battery management system, but again, this is considered an instrumental safety feature in the energy storage system. It should be considered the eyes and ears of the battery system's health. The device is monitoring constantly the state of health of the energy storage system, and if the BMS were to fail, you're losing a critical safety feature. So in NYSERDA's own review rubric, this is one of our critical failures if there's anything wrong with the BMS. Next slide, please. The health of the energy storage system must be monitored 24/7 by a staff facility. This is one of those fire safety working group recommendations that made its way into the 2025 code. This was based on the work that FDNY had done in New York City. New York City has been requiring this remote monitoring system, remote monitoring center, or network operations center since back in 2019. Again, that magical year for energy storage, safety regulations, that watershed year. This is something that the fire safety working group looked at what New York City was already doing and the work that FDNY had already done and said, you know what, that makes a lot of sense. We're going to find a way to make this requirement apply statewide, and that's what you see here. So 24/7 staffed remote operations facility to monitor that battery management system data is required by code, and folks who are submitting project applications should show proof of contracting or internal capabilities with a remote operations center. Next slide, please. And we have another quiz question here. What are the functions of a battery energy storage management system? Is it A, monitoring cell voltages, currents, and temperatures? Is it B, the ability to isolate malfunctioning cells? C, ability to notify the system operator if a malfunction occurs? Or D, all of the above? Give folks 2 or 3 seconds here to try to catch us up on time to come up with the correct answer in the Slido for credit from Department of State to show us that you are still with us and paying attention. The correct answer is D, all of the above. The battery management system is a wonderful device that can do all of those things. Can we go to the next slide, please? This one might feel like a no-brainer. It is required by code nonetheless. In 1207.3.5, all ESS should be made of non-combustible material. This is to contain a fire if it should happen within the enclosure so that the heat does not transfer to other enclosures. That will, as Paul said, be validated by data from the UL 9540A large-scale fire test report. Next slide, please. Electrical disconnects are extremely important to first responders, and they should be in a secure location with signage to direct the fire department to the proper place. Even though you may shut down the energy storage system, the stored energy inside the batteries does not dissipate the energy. That is a key point to bring to first responders. This one device can shut down all cabinets or containers that are at the site. Firefighters should be advised to be careful when shutting this system down when there are no signs of fire. When there is a problem with a section of the system, the battery management system will generally isolate that particular section and stop it from charging and discharging. In the event of a fire, the fire department should seek advice from the subject matter expert, the hazard support personnel that Paul talked about before shutting down the full system at the location. Next slide, please. I think we've got a little more on disconnects, but for on the residential side, residential disconnects were updated with the 2020 National Electric Code. New York State skipped from 27 to 23, so we're actually ahead of the 2020 NEC. Residential energy storage systems now require an emergency disconnect, which is basically the equivalent of a rapid shutdown for PV. These additions and updates to the codes and requirements were made specifically with first responders in mind. Next slide, please. Got a little bit more on disconnects here. This is mostly just to show you what they might look like. It's not always a button. Sometimes we have the knife edge. There are different types, but they should be labeled. Signage requirements require that they are. So the point of these, again, is to make them readily accessible and identifiable by emergency responders in the event of emergency. Can we go to the next slide, please? So here we have working clearances. So working spaces that may be around the electrical equipment and the energy storage system. The clearance for working on the equipment should be 3 feet. The National Electric Code NFPA 70 require this. These clearances should always be unobstructed. Fire departments that may go out to do a site visit should notify owners of the equipment when they are not in compliance with the regulations. So if folks are AHJs or representatives of the local fire department see less than a 3 foot clearance while the system is under construction, that is something that should be brought to the local jurisdiction and addressed. Next slide, please. Energy storage, we're in fire resistant separation now, so we're looking at primarily indoor. So if an energy storage system is inside a room or area that is indoors, that room or area shall have a minimum 2 hour fire resistance rating on all sides. That includes the ceiling of the room. That is something that comes up a lot to the clean energy siting team and our experts. Yes, if there is a room or area with an energy storage system in it indoors, the ceiling also needs to have that 2 hour fire resistance rating. Next slide, please. Seismic and structural should probably be no surprise that that is also addressed in the code. The building architect should look at this requirement in 1207.4.4. This is a reference code to the building code of New York State, and you'll see that buried in a lot of code language. So it is important to look up that reference and certify that the design meets the requirements in the building code. Next slide, please. Vehicle impact. Obviously there are areas of where this is more concerning than others, but inside a garage would be a big one, as well as certain outdoor sites that are adjacent to a roadway. So the code requires vehicle impact protection. Those are typically concrete bollards, as you see in the photo here, that are going to stop any sort of collision between a vehicle and the battery. Again, pretty standard stuff for the fire code. I believe the fire code also has a design, a few images in there of what that could and should look like for vehicle impact protections. Next slide, please. This is a big one, combustible storage. Another one that should kind of be taken for granted. Unfortunately, that's not always the case. We don't want to store things that are combustible near the energy storage system. As we saw on the graph at the top of this presentation from Electric Power Research Institute, or EPRI, failures are very, very rare, happening in a fraction of a percentage of installations and a fraction of 1 instant per gigawatt hour of deployed capacity. That said, that's not never. And as Paul said, this is not a fire elimination code, it is a fire prevention code. To that end, the fire code requires that there be no combustible material within 3 feet of cabinets containing energy storage systems. This is critical, and it is one that unfortunately gets overlooked. It is one that NYSERDA's field inspectors are looking out for. It is one that is required to be looked out for in those recurring inspections that Paul talked about as well. Very important that no combustible material is stored within 3 feet of an energy storage system. Next slide, please. On to toxic and highly toxic gases. This is, again, primarily indoor, inside walk-in units. Lithium ion doesn't release any toxic gases during normal charge and discharge operations, and therefore is not required to ventilate, which we'll get into in more detail later. Some batteries that are not lithium ion may release toxic gases during normal charging and discharging. Those are regulated by the code separately, as I will get into later in the presentation. Force fan system used in battery charging rooms and other areas where gases can build up is required in some instances, and best practice in others. Again, we'll cover that more later. Next slide, please. Signage. This is a big one. This is another one that the Fire Safety Working Group really got a lot of new and novel requirements related to signage into the 2025 Fire Code of New York State. Most notably the site map that you see at the bottom. There has to be a hazard map here on the outside of the fence line of the system so that first responders understand where the areas of hazard are within the system, in the system site rather. In addition to that, we need signage that identifies the system as an energy storage system, what type of battery, standard NEC, National Electric Code signage requirements like that there are energized electrical circuits. Critically, we need that hazard support personnel or fire mitigation personnel that Paul was talking about, those subject matter experts that are going to come to the site and assist the fire department. Their contact information needs to be on the signage on the outside of the fence. That we are looking at our peer review team to make sure that that is the case within NYSERDA. It is also of critical importance to make sure that the code officials are also checking that that is the case before issuing a permit. And then next slide, please. We have one example of a hazard warning. Oh, sorry. The signage requirements in terms of what they are supposed to be, that is outlined in the National Electric Code. And then we also have the one example of a hazard warning that Paul and I talked about where we have deflagration venting. A deflagration vent is something that kind of pops to vent gas if there is a buildup of flammable, of explosive gas in a container. It's designed to pop to vent that gas to prevent an explosion. That's a simplified version of it. Sometimes that pop of the vent can pop off of the container. So part of that site map and hazard warnings on the signage needs to identify if that happens, if there are deflagration panels, the site map and hazard warnings need to identify where they are as part of the signage requirement. And they also need to identify where that vent might land if it were to blow off the system. So these are the types of things that we're looking for in the code requirements when we talk about hazard warnings. I'm going to go to the next quiz question on the next slide before turning it back over to Paul, and hopefully we made up some time and we can get through this in the remaining 45 minutes. What is not required on the signage for entry doors for energy storage system rooms, areas, cabinets, or walk-in units? Is it A, the name of the company who installed the system, B, the battery type, C, the contact info for the hazard support or fire mitigation personnel, or D, energized electrical circuits, which is not required. Going to give folks maybe 3 more seconds before I blurt out the answer so we can move on. A, the name of the company who installed the system is the one of those 4 things that is not required. And with that, I will turn it back over to Paul.
Thanks, Bill. We can go to the next slide. Great. Okay. Yeah, we definitely going to move on a little quicker now. Like anything, right? We need to have some sort of security installations. The code just adopted something I thought was really good, and that is having some sort of video monitoring at the site itself and making sure that is working. That should be something that the subject matter expert should have some sort of access to in the event that they're guiding the fire department during a failure event. Not only the battery management system, what I mentioned before, to take a look at the state of health of the battery, but also to have the closed circuit TV because something else may be going on that may be outside the batteries themselves. So I think that was a great add-on for the state to do something like that. But like anything, they need to have any type of security fencing that's out there. I think that's a local zoning issue that we got to make sure that we stay within those height requirements that the zoning the zoning allows in their particular area there. We also want to make sure that these do not inhibit any type of required airflow. As Bill mentioned, one of the things that they have is making sure that we can pull gases out, and we want to make sure that if that fan exhaust is not going to be blocked by anything outside. So keep that in mind. Some of these things may be on the rooftop, and we need to take a look, making sure that there is nothing in there obstructing that in order to pull those gases out to try to reduce any type of concentration of gases that build up on the inside there. So we try to prevent any type of explosion from taking place. You can go on to the next slide. Occupied work centers. Okay, here's a good picture here. The occupied work centers, and what we've seen on our end is they need to be right locked in non-combustible cabinets or enclosures, but we are seeing a lot of these things more on the lead acid base side for these battery energy storage systems. Doesn't mean that they can't have lithium ion, but again, if they do, they make sure that they've gone through some sort of testing on that end and have all of their required 9540 listing and any type of system that is going to both thresholds that are in the code need to have that 9540A listing itself. So really make sure you take a look at this when you're getting into these occupied work centers on that end. And it should be within 10 feet of the equipment that is actually supporting, and that's in the code, just a FYI. You can go to the next slide. Open racks, once again, we have seen things out there that have been in open racks. They are allowed to be in open racks. They're usually in a separate equipment room, and only authorized personnel can get in there. For those rooms, making sure that that there is some sort of signage on that front door for the actual fire department or an electrical disconnect is important too. Even though we mentioned it before, it does apply in this particular case right here where we don't want the fire department going in there. And they should be aware of what's going in there and what type of chemistry that's involved in the room itself. All of that stuff should be incorporated into any type of installation where you have an open rack installation inside a room where only authorized personnel should be in there, or any room actually. So you can go to the next slide. Walk-in containers. So there is a definition for walk-in containers in the code itself. And walk-in containers or walk-in units in this particular area really was treated as if it was a building. So that means someone can actually physically walk on the inside of that thing to do any repair, replacements, and maintenance of the battery energy storage systems. They are required to have a sprinkler system on the inside, a sprinkler system, because it's treated as if it is uh, an indoor installation. This is not should not be equated to the cabinets where no one can walk in there. And there's a definition on that. We really need to make sure that we know the difference between them. Where if you cannot walk into it, into the system itself, it's considered a cabinet and does not require the sprinkler system that I just mentioned before. So it's important that everyone understands the distinction between that. And one of the reasons is that people going inside, that makes it a life hazard where you can't get on the inside of the actual battery cabinets themselves. The life hazard isn't as prevalent on that end. So we can go on to the next slide. Fire safety and compliance. This is from the electrochemical side and the BES. If these things are going in, size and separation, the maximum allowable quantity that you can have inside a room is 50 kilowatt hours. So we call them groups, or that's what I refer to them as groups. As you can see in the diagram here, we have 4 groups. Each of them have to be 3 feet away, even from the walls themselves. Can we go higher than that number? The answer is yes. But if you're going to go higher than that, then you're going to have to do the large-scale fire testing to make sure that you cannot have a failure that's going to propagate to the adjoining ones. But that's all based on large-scale fire testing on that end. Can you go closer to the wall? Sure you can. And that will also be based on the large-scale fire testing. So there is a way out of that as long as you do the proper testing and it is approved by the local jurisdiction on that end. But if you're going to stay within the guidelines and keep at 50 kilowatt hours, we're going to have to stay 3 feet in all areas. And it could be even further than that, to 3 feet, if there is a maintenance area, right? And the National Electric Code actually drives that. So you could see things as far as maybe 4 feet, but that's only because it's based on the National Electric Code on their maintenance of these things on that end. So there could be things in there that you have to take a look at. You can go in the next room. Okay, the MAQs, the maximum allowable quantities here, and this is in a section, right? So it gets into the maximum allowable quantities. Can we go above these maximum allowable quantities? We sure can. We definitely can go into the above these numbers here that we see. As a matter of fact, if you take a look at most of the battery energy storage system cabinets that are already out there, they already exceed this number. They're already above and beyond these numbers in that case. And How can they do that? They can do that by doing, again, the large-scale fire testing and a hazard mitigation analysis. And that gives you the right to actually go above, but you have to, again, show in that data collection test that the system will not propagate or spread to the adjoining systems that are next to it. So even though these are the MAQs, and there is a way out of that by doing large-scale fire testing inside the rooms, areas, working containers, and even inside the cabinets themselves. So just so you know, these are just thresholds, and I wanted to make sure that you understood those thresholds. Take a look at what we have with lead acid and what we have with nickel cadmium. They're unlimited in that end. They have gotten sort of like a way out of it because of the fact that um, a lot of the telecoms are using lead acid on their end, and they've had a great track record. They also have to comply with another NFPA 76 number. But I'm sure people are questioning, why does lead acid have unlimited or those? And that's because these chemistries have actually been out there for a very long time with a great track record. So they gave them some sort of leeway on that. You can move to the next slide, please. Okay, we don't see this often, but there is a section in there where if you did have a lithium ion and you had some of the chemistry that is associated in the same particular area or in the room itself, um, you have to you have to go through and take a look at the aggregate amount, and then you have to do this total aggregate, and you have to you have to show that if there was a fire on each one of them, whether it's in this case a flow battery or in a lithium ion, that it would not actually have any adverse effects to the adjoining ones, whether it's on fire or any other type of leakage in some cases, that it would not affect the adjoining or the other chemistry in that area. And that should be done as part of the hazard mitigation analysis too on that end. So we can move on to the next slide. Elevation, we see this quite frequently, that 75-foot parameter. In a lot of the codes out there, this was also baked into the code itself. You cannot locate these things above the 75-foot, and they usually used a ladder, a 100-foot ladder, aerial ladder, and that's how they come up with that number. But it is from where the fire department can actually access it too, right? So it's where the vehicle actually accesses from there. Floor is located the level of discharge too. So we can also look at elevation, and we can look at subterranean stuff where the fire department may be able to get down there from an outside exit that goes to the basement itself, and they can be they can be approved based on that. We can go to the next slide. Fire detection. Again, this wasn't required in the original code, but now we have, well, fire detection was, but a central alarm station was not required in there. And a central alarm station, for those who don't know, is basically something that is going to you'll activate a fire detection system, and it will send a signal to a 24/7 monitored central station, which will actually dispatch the fire department. And that's important. And that was a big deal to get that moved forward. Even the NFPA 855 standard does not have that requirement for cabinet style systems themselves. But the state put that in there. I thought that was a great add-on, and then that they actually do that. And there's other examples of it, which is a VESDA, very early system detection apparatus. It's an air sampling, and that may be for things that are outside of lithium ion. It could be lithium ion too, but basically it's an air detector, it's sampling, and if they get some sort of sampling, it's constantly looking at the gases inside the room itself, and it can set off a signal to actually get the fire department running. What we also have seen out there, and this is becoming common, is more common, is these IR detectors that are out there. The IR detectors are really looking for flame. Most of the time they're looking for flame. In some cases it could be heat, but all of that would actually trigger an alarm to get the fire department actually rolling on that end. And there are some people that actually like these as opposed to a smoke detector because They don't want to go to false alarms, so they are looking at IR detectors as a way. Doesn't mean that you can't use the other ones. I'm just telling you what's happening. What we're seeing out there is some people are concerned about nuisance alarms, although we haven't seen that too many nuisance alarms to get the fire department ruling, which is a good thing on our end. So that's important for the volunteers that are on the call here. You can move on to the next slide. Okay, question number 6. True or false? For lithium-ion batteries exceeding 600 kilowatt, as mitigation analysis and large-scale testing are both required. Is that true or false? Give you a couple of seconds here because we are pressed for time, so we got to make sure that we capture everything moving forward. Okay, the answer is yes, right? They are both required. So let's move on to the next slide, please. Fire suppression systems. Automatic fire suppression for indoor installations. If you could take a look at this one, this is a little different here, right? I'm sure people are saying, wait a second, there's a fire suppression system and that's an outdoor system. That's a cabinet outdoors. No, that's not a cabinet. That's an indoor, that's technically a walk-in container. As you remember what I said before, walk-in containers are considered to be like a building. So they do need to have a suppression system on the interior of the box itself. And if you're putting in there a sprinkler system, the minimum amount that you need to put in there, the minimum, is 0.3 gallons per minute per square foot, or determined based on the large scale fire testing. So if you want to go lower than that, you have to prove it by, hey, showing that the large scale fire testing actually can do that. If the large scale fire testing says, hey, you need to go higher than that, then you have to be based on that too. So that is just some guidance that the committee put out there, and it's important that you know that. Uh, you can also see there could be all other alternatives out there, systems that are out there for fire suppression. Here's what I would tell you. Take a look at what they're used for. Make sure that if they're telling you they're using a different type of system for suppression, that it actually works. Ask for the data, ask for the testing that has been done with it. In some chemistries, hey, the clean agents may work, or a fixed aerosol may work. In some chemistries, and other chemistries it may not. So make sure that you know that that these things that they say are going to work will work. Because we have seen things out there where people are trying to sell things that may not necessarily work, but they're given the impression that they do work. So we can move on to the next slide. Oh, in yellow, hold on a second. Can you go back 1 second? Sorry about that. I don't know if you can go back. But in yellow, it said there, it's not required for outdoor systems itself, right? Do not need a fire suppression system. Non-walking containers do not need a fire suppression. That's important when you're actually doing a review. Next. All right. Oh, okay. Indoor systems here is just kind of giving you what it would look like. Here's a water system here, and a sprinkler system. That has to be 0.3 gallons per minute per square foot, as we mentioned before. If there's a gaseous system, all of these things still need to be inspected, right? We need to make sure that they work for game day, and it's important that we do that type of inspection out there. I know for the gas ones, there are special inspections that are out there that we've seen performed. In some cases, you could have both a suppression system that is aerosol and a water system. And maybe the suppression system for the aerosol will be activated before the sprinkler system. Maybe we'll actually try to reduce any heat, so this way the sprinkler system is not activated as a result of that. So we've seen that out there too on that end. It works with any type of chemistry, but make sure that if they're telling you it is going to work, make sure there's not going to be any adverse effects as a result of that. And if this stuff, especially aerosols, if they get released at an incident, make sure you ask questions about did it compromise the actual battery energy storage system as a result of the release of the battery of the aerosol? If it did contaminate the actual batteries, can they be put back in service and just a replacement of the extinguisher system? That's important to know. Next. So there is a something in code that just really gives you dimensions on what the highest maximum enclosure size for an outdoor walk-in container. Now, we haven't seen any of these things bigger on the cabinet style, but the outdoor walking container basically gives you the actual maximum allowable dimensions here, and here's what they are. It's similar to what we see with the intermodals or Connex boxes, some people like to call them. That have been repurposed. You can move on to the next slide. Vegetation control, they want at least 10 feet, at least 10 feet. But if you feel that you need to go further than that and just base it off your 9540A testing to show that, hey, you know what, if this thing were to actually go on fire, the heat release rate or the heat flux may be further than 10 feet. And also keep in mind that we want to make sure that the branches that reach over are not going in within a 5 foot radius. That's not what the intent of the code was. It was really just to keep any vegetation, and the branches included as they extend out and it grows over time. It's important that you keep that on your end up to date, and that should be part of the annual inspection. Next. Means of egress and separation. Again, they want to make sure that these things are at least 10 feet from there. And that is no less than 10 feet means that, yeah, you can go further on that. But again, we want to try to justify why we're saying it needs to go further than that. And again, you can point back to your large scale fire testing. As you can see, we're going back and forth all the time back to that large scale fire testing, making sure that everyone knows how you can utilize the data. We can go on to the next slide. Thanks, Bill.
Thanks, Paul. I'm gonna hop in here to talk through some of the technology specific. This table you will see in the fire code. So you'll see here, this is all electrochemical. You have different requirements that apply to lead acid, nickel cadmium, lithium ion, and so forth. These are outlined in the code because we do not treat all these systems equal, since they all have their own unique hazards, makeups, and chemistries. Next slide, please. We've got a question here to see how well folks retain information. Do all electrochemical BESS types require the same fire safety requirements? Yes or no? Give folks to answer the second to answer this in the polls, although we are going to keep moving quickly through this section and the next one to give Paul plenty of time to get through the heart of the presentation toward the end, or the last heart of the presentation. This one has many hearts. That's enough stalling while you answer. No, many safety requirements vary based on the hazards associated with each. Explosion control. This is not something that we have for all types, but it is something that applies to lithium ion. We have two main NFPA standards that apply to explosion control. That's NFPA 68, which is the deflagration venting, which are those vents that pop up when there is a critical mass of gas built up inside the container, and NFPA 69, which is explosion prevention. Explosion prevention systems are aimed at keeping the gas buildup within the container at below 25% of the lower flammable limit of the gas mixture contained. It is important to understand that not only NFPA 68 and NFPA 69 are viable options. We do check for deflagration analysis both in the UL 9540 listing and through NYSERDA's peer review to verify that the data behind other types of explosion systems that don't meet 68 or 69 does justify that that system works to contain the hazard presented. Next slide, please. We've got flammable gas exhaust ventilation systems as well. This is part of the NFPA 69 explosion prevention. These are also called combustible concentration reduction systems. Air intake is generally best toward the bottom of enclosures to ensure airflow through overall interior, and the system pulls hot gases up and away from the enclosures. So a simple exhaust system. Next slide, please. Explosion control under the NFPA 855 standard, which again is the parent standard, is not always required. We have some exceptions here. If the UL 9540A large scale fire test shows that there is no flammable gas at the cell level or the module level, then we don't need that, obviously, because again, data driven decision making, data driven requirements. If you can show documentation that the system cannot possibly generate more than 25% of the lower flammable limit of the gas under thermal runaway conditions, that's also going to get you an exception. I'm not going to read through all of these for the sake of time. They are in this presentation, and more importantly, they are in section 1207 of the fire code. Next slide, please. This is the warning sign that I was talking about under the signage section. If you have those deflagration vents that are going to pop up to vent out explosive gases, if there is a critical mass buildup of the explosive gas in the container, we need to have signage that shows where that deflagration vent will land should it pop off the system entirely, because again, that is a life safety hazard to first responders in the event of an emergency. Next slide, please. A gas detection system is also going to be required specifically for that NFPA 69 explosion prevention standard to monitor the level of gas in the unit. So I keep saying with below 25% of the lower flammable limit, how are you going to know that you are below 25%? You are going to use the gas detector. The NFPA 72 standard also has regulations around the signaling that comes off of the gas detector if there is an issue. So we pull in the NFPA 72 standard to make sure that the notification chain is working the way that it's supposed to be and going to the right folks. Next slide, please. Thermal runaway is something that has come up quite a few times in this presentation. Here's a very crude illustration of what that actually looks like. It is important to understand that once thermal runaway is initiated, it is an exponential rise in heat that cannot be stopped. So you can't reverse it. All you can do is contain it. So thermal runaway can spread to adjacent cells. This is what we're testing for in the cell level 9540A large scale fire test to see to what extent that thermal runaway propagates from cell to cell. Certain BMS systems are able to isolate problematic cells and be able to shut it down with the intent of being able to control these thermal runaway incidents should we be unlucky enough to experience one. Next slide, please. I'm going to go through the non-lithium ion electrochemical protections especially quickly because, again, all of these apply to non-lithium ion, so typically lead acid, flow batteries, nickel cadmium, which, again, we don't see that much development of these types of technology in the market right now. So exhaust ventilation is not required for lithium ion because, again, during the normal charging discharging operations of a lithium ion battery, we are not seeing toxic gases. That is not true for lead acid batteries, for flow batteries, for nickel cadmium. So we do need exhaust ventilation required for those types of systems. Next slide, please. Some other types of energy storage systems have either corrosive or otherwise dangerous electrolytes, whereby if the electrolyte is released or spilled, that will cause some serious issues. So for lead acid flow batteries and others, we have a spill control and neutralization requirement in the code. That is not true for lithium ion because lithium ion electrolyte does not present a danger in itself. Next slide, please. If spilled in itself, if spilled. Safety caps. So this is basically to again deal with gases that are released as part of the normal charging and discharging operations, which lead acid, for instance, will release hydrogen. Safety caps will mitigate basically the buildup of that hydrogen. They will release similar to a deflagration panel. You do not need that again for lithium ion batteries because there is during the normal charging and discharging operations no buildup of that type of gas. We only see buildup of these gases and off-gassing in lithium ion systems as a result of a catastrophic failure. So during charging and discharging operations as they normally occur, we don't see these hazards presented by lithium ion batteries, and therefore they're not regulated in lithium ion batteries by the code. I'm going to hand it over to Paul again for the next slide to go through some location specific. Oh wait, we have a quiz question. Do lithium ion batteries require spill control neutralization? Yes or no? Do 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 do. I'm not going to do the whole song. No, they do not. the electrolyte is not in liquid form. Paul and I think, are going to tag team a couple of these, but I will turn over you to Paul to lead off the first few here.
Great. Thanks, Bill. So yeah, we're getting into site-specific locations. The code actually talks a little bit about different locations where we may see these things, and they give prescriptive requirements on what needs to be done if you go into those specific locations. We can go to the next slide. Okay, here, just like we said, some modern installation scenarios that we have. We have dedicated use buildings that's inside the code. We have non-dedicated use buildings, outdoor near exposures or outdoor remote. And we'll talk a little bit about that. You can go to the next slide. So this is just a table that gives you some guidance and kind of summarizes some of the things that you need to be aware of when you're looking at either a remote location or locations that are near exposures themselves. I would actually check in with the actual section and see what the verbiage says in that particular section of that. For instance, if you see size and separation 1207.5.1, make sure that you take a look at that on your end. It gives you further guidance on it. Move on to the next slide. Next code, next slide. All right, so as we mentioned before, there's remote outdoor. That's anything 100 feet away from lot lines, public ways, stored combustible materials, has some material, high pile stock, or other exposure hazards. And they're not talking about the batteries. They're talking about other exposure hazards, not the actual containers that are alongside of them. And then installation near exposures are what we see here. So these are two examples of an outdoor remote, and then what we mean by an indoor, a one that's near an exposure. We can go on to the next slide. Okay, so this is a good example of what an outdoor remote. They don't need to have any type of expression system if they are walking containers. If they're walking containers, right? We already know that we don't need them on the cabinet style, but if they're walking containers, they don't need any suppression system. If they are remote, and they fit that category of remote, then they do need some sort of suppression system, and that is for the working containers at all. They're not subject to the MAQs, so they don't have to do that. They don't have to worry about the MAQs, and they're not subject to size and separation. And how are they done? How is that done? That is done through all 9548 testing. And you could see when it was first drafted, one of the things that we saw in the committee on this particular section is that the remote systems, a lot of people were having a difficult time going through testing, and it cost a tremendous amount of money. So what the code people did is they said, okay, well, if you can't do 9548 testing, which almost everyone is doing today, if you can't do that, then the penalty would be you cannot be within 100 feet of an actual system, of an actual exposure itself. And that's how remote evolved into the actual code itself. We can move on to the next slide. Do you have something to say on that, Bill?
Yeah, I would just jump in there to say that you'll see this language, and Paul's alluding to it there, a lot in the code that's exceptions based on large scale fire testing. There's some language like based on approval of the fire code official of large scale fire testing results. And I think it's important to understand the intent behind that for the purposes of this webinar. And that is not that necessarily that the fire code official has the authority to disregard the large scale fire test results entirely. That is not the intent of what that language is saying in 855 and the code and other places we see it. The authority granted to the fire code official in the code is specifically the authority to confirm whether or not the siting decisions that were made in the project design are consistent with the data from the large scale fire testing. So the code is not saying, based on the intent of the folks who wrote this, Paul being included in those folks, that we can just disregard large scale fire testing results and say, no, we don't want to use that at all. The fire code official's authority is to say, yes, these siting decisions are made in accordance with the data from the large scale fire test, or no, these siting decisions are not supported by the data from the large scale fire test. So I think it's just important to kind of clear up where that authority lies, because that language appears over and over again in the code.
A great add-on, Bill. That is so important, right? And that was the whole reason behind the large-scale fire testing, is that basically prove what you're doing is safe. Prove what you're doing is going to be something that the fire department could do. Can you go back just one One slide, please. So here's an example of an outdoor near an exposure right here. How did they do it? They actually, you can see that is, so you know, that thing in the background there is a combustible liquids in there. It's diesel fuel that's inside of those, inside of that container, and it's so close. And a lot of people would be like, "How the heck?" Well, you know what they did? They leveraged the 9548 testing, and they saw that if this thing were to actually go on fire, the heat would not compromise or have any effects on the system that's over there and that's next to it, the container that's next to it. So you can see how they're leveraging of that on their end. And also take a look at how these things are raised off the ground, and that is because there was a concern of potential flooding that's there. And I think it's the 100-year storm, a couple of 100-year storm, whatever it may be. But they did move them up, and this is above and beyond what the levels of would be. So really did try to make it work as best they could to protect them as best they because it was a good location, except for you know a couple of things that we see here. But they did account for all that when they took a look at this moving forward. Let's move on to the next one. Thank you. Next slide. Great. Okay. So these are the things that are applicable to both the remote and the indoors, the near the exposures themselves. And I would just make sure that everyone takes a copy of this. This is kind of self-explanatory, but it's applicable to both. We can move on to the next slide. And the clearance to exposures, I think we said that uh, the minimum is 10 feet from the lot line and public ways and buildings and so on. We want to make sure that there is a 1 hour fire barrier 5 feet above, and that really gets into uh, the residential part of it on that end. But the minimum is 10 feet. Can you go further? Yeah, but again, using the UL 9540A testing results will help you to actually say, yeah, we went further based on whatever, whether it's heat flux or whatever it may be on that end. So we can go on to the next slide. All right, outdoor installations, just a question. Outdoor installations, which safety requirements are not applicable if the installation is considered remote. That is correct. D, A and B. Move on to the next. Okay, this is again just giving you an idea of what it looks like for an outdoor installation, just what you should see on there. We do have the maximum size of the enclosure size needs to be adhered to, means of egress for people to get out, security of the installation with the fence there, the HVAC systems and how they're actually incorporated in there to make sure that they're working properly on that end to cool down anything that may overheat as a result of that, making sure that it's working when we need to. And also we see that we have exhaust ventilation. Remember we talked earlier to make sure that those exhaust ventilation systems there, that they're there, that they are not blocked in any way to make sure that we can get the full gases out without any inhibitions on the actual exit points at that point. We can move on to the next slide. Okay, again, this is showing you distances here. An outdoor installation, they're giving the example of a 2 megawatt, 4 megawatt hour. So it's a 2 hour system per enclosure. Um, if you can take a look at number two there, they're 6 inches apart, right? It's showing the separation distance between cabinet is 6 inches apart. How'd they do that? They actually tested it that way. They tested it. The code says it's 3 feet. They tested it and said, no, we want 6 inches. They said, okay, you want 6 inches? Then make sure you prove it and do the large scale fire testing to prove that this thing will not propagate or spread to the adjoining one. And that's exactly what they did. They had 6 inches from back to back, 2 feet from side to side. And again, when they did that large scale fire testing, they actually had to set it up in the orientation on how it was going to be installed at that particular point. Number four is really just between front to front, and that's usually dictated by the work that needs to go in because they need to do maintenance on. They need to make sure that they can open up the doors completely and that they can do the maintenance that's required. So that 8 feet is actually in the National Electric Code. And then as you can see, number five there is just showing a fence that is 10 feet. Now, I know there are some areas that have zoning where zoning should be I'm sorry, it's 10 feet from the actual wall, but getting into the fence size should be based on your local zoning at that particular point. But they want them at least 10 feet. They can go further than that based on what the code officials say, and they can back that up by using the 9548 test results from that end. So you can go on the next slide. Okay, so this is just some pictures of some cabinets here, right? This really here is something that we really need to make sure that you understand. In some cases, they build out the pads further than that are occupied with no battery energy storage system. What we see in the future is that these things will start to get some augmentation involved in it. And they'll be bringing in new systems. We want to make sure that these new systems are both compliant. It's almost like a new installation. They could be bringing in the exact same system, but maybe 5 years from now, it's going to be a different system. We want to make sure that they are doing the right work on that and that they are actually putting them in safely. The separation distances, if they're going to be 6 inches, how they get that 6 inches? Did they use heat flux analysis from the number one versus number two? That new system has to have 9540, 9548. All of that stuff needs to come in there to make sure that when they do go augmented, that if that system were to actually fail, it doesn't propagate to the original systems that are already up and running. So all of that needs to be incorporated on that, and they should get a permitting review on that end too. So just keep that in mind that we will see this down the road. Next. Okay, so this is something that we kind of said time and time again. This is what we mean by a non-walking container. A person cannot fit in there. That is considered a non-walking container where no one can actually get on the inside of these things to do any repairs, replacements, maintenance of the system itself. Most of the systems throughout the state of New York, and we see this in the industry as a whole, are non-walking containers. And we'll probably see that from now on, where we'll see a lot of these outdoor systems being these non-walking containers. You can go on to the next slide. And we already kind of went over this, but this is just a walking container where you have to go inside to actually do any repairs, replacements, and maintenance of the batteries on the inside. So basically, you're walking into the container. It looks similar to it, but the other ones you can't get in. This one you can actually have a walkway in between the two racks there on each side of the wall to get in. So we can move forward. Great. Bill, are you going to take this one? I think you said.
Yeah, I can actually start here and just kind of bring us through the end.
Thanks, Bill.
Just a heads up that we're probably going to run a minute or two over and hope folks can stay with us. Exterior wall installations, those are typically residential, and we are still in the fire code. So the circumstances under which you see an exterior wall installation that's regulated by the fire code will be limited, and that is typically if the unit is above 20 kilowatt hours. Most residential units are below 20 kilowatt hours, largely for that purpose. Next slide, please. And we're going to go through very quickly what are some indoor installations. There's just kind of not that much to say here. We have a similar table to the outdoor. We have two types of indoor installations in the code. One is a dedicated use building, which is exactly what it sounds like, a building that is dedicated to the use of batteries. So a few things in the code are not going to make sense there. For instance, dwelling and sleeping units, if they're dedicated to the use of batteries, you're not going to have a dwelling or sleeping unit. Size and separation, you don't really need separation if that's really all that's going to be in the building. And then a non-dedicated use building is any other type of building. So a house, a hospital, a commercial industrial facility, anything else. Next slide, please. Dedicated use buildings, as I said, only used for energy storage, and very critically, no unauthorized access. And the only access is and should be for maintenance, and no more than 10% of the building can be occupied by anything other than administrative functions serving the battery. Next slide, please. Non-dedicated use buildings, as I said, anything else other than a dedicated use building, any other indoor systems, we will likely start to see these kind of proliferate more and more. Hospitals are a really good use case of uses that need backup power critically. And then, as we said before, commercial industrial applications for peak shaving and peak reduction, you would also likely see that more and more as time goes on. Next slide, please. To our fire barriers, once again, we did cover this. This is part of the general requirements too. 2 hour fire barriers per section 707 of the building code. And that includes, again, the sealing of the room or area containing the battery. Next slide, please. These are what we call special installations, meaning rooftop and open parking garages. You'll see this similar table whereby some requirements do apply, others don't. This one is the funniest because you'll see that for rooftop, open parking garage, regulations don't apply, and for open parking garage, rooftop don't apply. Other than that, everything applies. Next slide, please. Um, Clearance to exposures is once again greater than or equal to 10 feet. Those reductions can be down to 3 feet based on the large scale fire testing. Again, we like to use data driven decision making wherever possible, but the default is 10 feet, just like any other installation. Next slide, please. Fire suppression systems. They're also, these special installations are required to have fire suppression, but automatic fire suppression is not necessarily required for energy storage systems on the top of an open parking garage where there is no roof or ceiling. Next slide, please. Rooftop installations. Should have access from the inside of the building for first responders in the event of an emergency. The roof should also have a standpipe that the fire service can use to put water on the fire if that is necessary for that type of equipment. The energy storage system cannot be within 10 feet of that rooftop access that is also required. Next slide, please. Um, Last one before we move on to the residential code, which I will also get through very quickly. Ventilation systems that have smoke detectors that can close dampers when they detect smoke can have an energy storage system within 25 feet. Otherwise, we need to be 50 feet or more away from HVAC air inlets. Next slide, please. 2 slides, actually. We're going to go through the residential code now. This is section 330 of the 2025 Residential Code of New York State. We are in the home stretch here. This is the last section. Please bear with us. Next slide, please. These 2 slides, we can go to the next one too. These are all just different images of residential systems. That's what they look like. You're typically going to see them or you are certainly going to see them rather in one of these places. Per the residential code, residential systems are only allowed up to 40 kilowatt hours within a utility closet and storage or utility spaces. And that again has to be completely enclosed by a fire resistance rating and rated wall, including the ceiling. We can go up to 80 kilowatt hours in total aggregate capacity for residential system on an attached or detached garage or accessory structure on the exterior wall. But in that case, you need a fire resistance rated wall that the battery is mounted on. So between the battery and the living or dwelling space. And then outdoor ground mount, we can also go up to 80 kilowatt hours aggregate capacity for residential systems. Next slide, please. We have another quiz question here. A single family homeowner wants to install an energy storage system in their garage with a capacity exceeding 80 hours. Should it be installed in accordance with 330 of the residential code or 1207 of the fire code? The answer there, this is probably the hardest question or the trickiest question. The answer there is B. So since you're exceeding the 80 kilowatt hour capacity in the residential code, you are then looking to the fire code for how you deal with that installation if you're going to be able to permit it at all. Next slide, please. One of the key differences between the residential code perhaps and the fire code, or perhaps the key difference is, again, the residential code has to deal with units that are capped at 20 kilowatt hours. One Tesla Powerwall, for example, is 13.7 kilowatt hours. So each unit has to be below 20, and then the aggregate capacity has to be below 40 or 80 kilowatt hours, depending on where the system is located. And they need to be separated by a minimum 3 feet from each other. Next slide, please. Um, for rooms and areas containing energy storage systems, this is the fire resistance rating requirement. We need the system protected by no less than 5/8 inch type X gypsum board or the equivalent. And that is written out in R330.4 for more detail there. And again, that does include the ceiling. Next slide, please. Another one that is perhaps common sense to most folks, it is required in the event that it's not common sense, no energy storage systems in dwelling or sleeping units. Hard and fast rule there in the residential code. Next slide, please. There are only 3 more. Smoke alarm shall be installed in the area where the energy storage system is installed. Where a smoke alarm cannot be installed, a heat alarm may suffice. Next slide, please. Finally, in R330.9, there's an exhaust fan requirement. These exhaust fans will automatically turn on when gases reach 25% of the lower flammable limit in the room. These ventilation fans will also be needed when toxic gas is produced during normal charging and discharging of the energy storage, if that is the case, like in a lead acid battery or basically any other type than lithium ion, where that is not the case. And I think being that it's 301, we can go to the next slide. Thank you all for participating. Thanks to Paul and the whole ESRG team for presenting this with us. Also, thanks to Paul and the ESRG team for your expertise in the Fire Safety Working Group, advising the New York State Code Council, advising the Fire Safety Working Group. Also, thanks to everyone in the Fire Safety Working Group for helping us really create some of the strongest regulations in the country for energy storage systems. We have some helpful links here that you can look at, and we also have contact information for the clean energy siting team at NYSERDA. Thank you so much for your time and attention. We are at exactly 2 hours since we began at 1:02. Thanks again for sticking with us.